Great. Warm welcome to another episode of the Monday Morning Learning Podcast, Season 3, 2026. Excited to have Sabareesh Kappagantu as our guest today. Warm welcome, Sabareesh. Any welcome words before we start off?
Thank you, Ravikant. I'm very excited to be on this podcast. So one of the first few podcasts that I'm part of, and I'm really excited to learn and share and have a good time.
Sure. Great. So, Sabareesh has spent over a decade building software at the intersection of AI and engineering, from IBM Watson, where he worked on customer experience analytics and behavioral data platforms, to Acoustic and now AVEVA, where he leads engineering teams working on industrial software at serious scale. Now, what makes him different from most engineering leaders talking about AI right now is that he's never stopped being hands-on. He's shipped production mobile apps end-to-end with AI as a co-creator. He reviews code, he writes it, and that proximity to the work shapes everything about how he thinks about AI adoption, not as a mandate, not as a productivity metric, but as something that has to earn its place inside real teams and real code bases. Now, he leads Aviva Tech Blog, holds patents from his IBM days, and has one of the more grounded, friction-aware perspectives on what it takes to make AI stick. So again, warm welcome to you, Sabareesh. Uh, let's
Thank you.
start, let's start with the first question. You actually described AI's best role in engineering as quiet infrastructure, not a featured capability, not a badge, but plumbing. And most teams are nowhere near that. So let's start there. What does an engineering workflow actually look like when AI is genuinely invisible but essential? And how far is the average team from that today, Sabareesh?
Uh, I would say the moment AI becomes a badge, something you announce in a meeting, it's already in the wrong role. Quiet infrastructure means it's doing work that would otherwise slow us down, and nobody stops to notice that it's there. Uh, so one of the things at any organization, the concrete expressions of how this is how you would embed AI context directly into code bases.
Hmm.
You add markdown files strategically into repositories, descriptions of expected query behaviors or search behaviors, guardrails, architectural intent that will help a model or an agent understand how to work inside that code base. So it understands not just what the code does, but how we build things in an organization. So it kind of has the institutional knowledge of a developer on a team.
Sure.
So the AI isn't a visible layer on the top. It's informed by the same documentation that humans are. So a developer will refer to a design documentation or an architecture wiki, and it operates within those boundaries quietly. So it's important to invite AI to that information, either by putting it in places where the AI can access it via an MCP or a tool call on an MCP server, or embedding it within the code base. Uh, the test that I use is if you have to explain to an engineer that AI is helping with this workflow, then it's not quite infrastructure. When it just works, that's the goal. So a good example is when our interns arrive in the summer, we are working on building onboarding agents that when they come in, they I don't have to explain to them how the agent works. I just point them to the agent and say, you can learn everything about the code base that you need here. It will guide you through your first user story, and you'll be able to submit code, walk you through how to submit a PR, what are the standards in which you should implement something. That's sort of what I meant by saying like quiet infrastructure.
Sure, Savrish. And for the audience, we'll be looking at, I think five themes. That's the base question which we started off. So we look at from segregation to integration, the evolution of AI and engineering from Sabrish's perspective. Then we look at guardrails without bureaucracy, governance that engineers actually follow. Theme three is on architecture, the speed of reasoning, not execution. We'll also look at culture before compliance, building teams that question AI and not follow it. And finally, some more questions on the new engineering manager, curator of context, not coordinator of execution. So, Sabrish, we'll start with the first one now. Now that you actually built up the base for the podcast, at IBM Watson and Acoustic, the AI and engineering teams were largely segregated. Now, looking back, what was the single costliest consequence of that separation, and what would you do differently if you were starting those orgs today?
Uh, I will start off to say that the time when I was at IBM Watson, I was a developer in deep legacy code. I was working very closely, sort of kind of giving context of my role there. I was working very closely with support to fix real customer problems. And what I remember most is how much of the work was actually just communication between support and engineering and customers and product management. Getting that chain of communication right was the difference between solving a problem correctly and quickly and shipping something that missed the point entirely. Uh, so the costliest consequence of having siloed teams, it wasn't like a duplicated code or missed pipelines. Uh, it was the broken communication that nobody catches. I will add a caveat and say that this is the time pre-Gen AI that I worked there. Yeah. While it was a behavior analytics product, we had AI teams working on predictive analytics, filling in gaps for missing data, and they had like real AI models built for the task and not sort of using Gen AI to kind of do the generalized kind of work that we're doing right now. But this problem still existed then. So when AI and engineering live in separate worlds, there's no shared language. So decisions made on one side don't translate cleanly onto the other. The cost will obviously compound silently until something breaks. If I fast forward that to today, and I think about Conway's law, how about communication between teams reflects the product architecture that you see. Conway's law says that your architecture mirrors communication structure, but when AI is infused into every team, every developer on a team, manager, product manager, everyone is using AI. We've added a new player into this whole conversation and communication scheme, and one that doesn't flag ambiguity. It doesn't say, "I'm not sure I understood that." They're extremely positive. The models are very supportive and very positive. It just produces. The goal is to produce an artifact and produce something. So the communication discipline I learned mattered so much at IBM Watson and Acoustic, and that becomes even more critical now when AI is in the loop. Because if human communication breaks down, the AI is not going to catch it. It's just going to amplify it. And if that gets amplified, then there's going to be like code drift and architecture drift, and the product architecture is going to look completely strange after a while. So if I was starting organizations today, I would embed that sort of AI literacy into every engineering team from day one. Not as a separate capability, but as a shared language that everyone speaks. So AI can sort of participate in the conversation.
Sure, Sabareesh. You actually describe AI's best role as quiet infrastructure. I think you started with that rather than a featured capability. So what does that look like in practice at AVEVA and other companies? Can you walk us through a concrete workflow where AI is invisible but essential, Sabareesh?
I think that the tooling aspect, what I shared about AI just being available and working in the background to when you're submitting a PR or validating a commit message or code that you've submitted without you having to think about it is sort of that are some examples of those workflows. Even like onboarding a user is an example of that workflow because it's going to get to a point, I feel, in the industry where people are not going to have to think about AI. I think we're getting there already. People are joining organizations out of college, or like people just entering a new organization come with the expectation that, oh, I'm just going to chat with the AI bot and figure it out. They have the expectation that that quiet infrastructure already exists. And that's why I'm saying the onboarding example is such a simple but easy thing to understand, because it's not something isolated to just the tech industry. It's like you're using these agents everywhere. You can have that in a financial firm, in a law firm, and whatever firm that you're at. Does that help the answer?
Absolutely. With generative AI now in the picture, every engineer essentially has their own AI interface. So how do you prevent that from fragmenting the shared mental model of the code base?
That's a very interesting question, because I think the first step is you standardize a tool because there's fragmentation right now at the tool level, there's fragmentation at the model level. There's so many models out there, so many tools out there. In our organization, we've standardized the tool where everyone's on GitHub Copilot, but within Copilot, engineers have the choice to pick their own model. And usually an engineer will choose a model depending on the task at hand. So and especially now with everyone increasingly thinking about token maxing and the cost of a token with the change in enterprise pricing, model switching is like a very active daily decision that people are making. A simple task will get a lighter model. A complex architectural problem is going to get a more capable and heavier model that costs more. So different models, different assumptions, different verbosities. Each of these models will spit out more language and code than the others. Different patterns are all landing into the same code base. So the tool being the same doesn't solve the problem in my lens. What solves is the actual context harness around these tools. So reliable AI outcome doesn't come from well-prepared data and clear prompts alone. It does help to have prompt templates, but it comes from the precise context design. So when the model has project history, standards, architectural decision, sort of like what we talked about earlier, baked into its context, you no longer have to explain the same setup over and over. And that's sort of the principle we're trying to build from at AVEVA. We embed our standards, our guardrails, our behavioral expectations directly into the repositories in markdowns that every model, regardless of which one an engineer chooses today or works from, the model switches, the context doesn't. Absolutely. If that makes sense.
Absolutely.
But I also will add on that context harnesses aren't enough for everything. Some things I believe should not be left to AI judgment at all. And that's where I think there should be some amount of deterministic workflows that should be set in place. For example, committing code to Azure DevOps or to GitHub or any version control. You can have a defined script that handles the commit process. The structure, the format, the process can be deterministic. What the agent and the AI can contribute to is the commit message, the content. It'll analyze the diff of the code that went in and figure out a PR description. It populated from possibly, again, a deterministic template. So everyone's PRs or outputs are consistent. So the creative contextual judgment can go to the AI, but the structural repeatable execution can stay in a script. So kind of separating that really helps. And the mental model that I'm starting to build and use nowadays is know which parts of your workflow can tolerate AI variance and which parts cannot. So for example, for reporting and triage, it's fine. Like I can allow the AI to have some flexibility because it's just reporting something, it's triaging what to do other agents or to some individuals. But for things like deployments to production, or for commit structure, or for PR format, it's better to always have these deterministic guardrails in place and let the AI fill in the judgment-dependent parts within them. And the context harness is, I'll also add this, there's another caveat here, which is the context harness is not a one-time setup. There's a failure mode that's more insidious than having no context files at all, and that is having context files that have gone stale. So your architecture decisions have changed, but you've not updated the context. So when a team's AI configuration isn't maintained alongside the code base, the agents keep generating code according to like older standards and standards that no longer exist. So the model will switch, the engineer might switch, but the context has to stay current. So that's like a new ownership responsibility that most teams haven't assigned to anyone yet. And I think that's like a very interesting thing to think about now. And I think there are a lot of principles coming out about it. I think it's the CEO of Google DeepMind, Demis Hassabis. There's this quote that he says, if you use AI in a lazy way, it will make you worse at critical thinking, but that's down to you as an individual. No one can help you do that. So there's a lot of intentional effort that people have to use, put into using AI and building these contexts around.
Absolutely. Absolutely, Sabareesh. You mentioned about guardrails. So let's look at the next theme on guardrails without bureaucracy. I think one of the sharpest insights is that guardrails must be lightweight and close to the code. So one of the questions I have is that you mentioned encoding unsaid rules directly into repositories, things like checking shared libraries before writing new helper functions. How do you decide what gets codified vis-a-vis what stays as team culture and judgment?
Uh, uh, I think the decision point is has it's sort of like, has this unspoken norm been violated at least once in
Hmm.
a way that costs us something?
Hmm.
If yes, it should get codified. If it's never been violated, then it can stay as culture. I think that's a rough rubric to kind of measure that and make that decision with. But maybe a concrete example could be like from from building an event management app that I did a while ago.
Hmm.
We had an implicit understanding that database migrations should be preserved, always ready to roll back if something breaks.
Hmm.
Uh, Nobody wrote it down, and again, this was before the 2025 Opus and I forget the model number, maybe 4.5, and OpenAI models came out that had like a significant improvement in their coding skills. Uh, so we started using AI to generate migration code, and the implicit understanding wasn't there for the AI. It didn't know our history. It didn't know why, so we codified it. Uh, every AI working in the code base, and we were a team, distributed team. Each person had their own subscription to a completely different tool and different platform. So every AI that working in the code base knew that it should never delete previous migrations. So the rule crossed over from us having like spoken culture into to a written rule the moment we had a non-human collaborator who could not absorb culture through this osmosis that humans will usually do, right, when in conversations. And that's sort of the threshold that I use now, because AI cannot read the room. It can't pick up on unspoken norms.
Hmm.
Anything that I would explain to a new engineer on the first week, but I don't write in docs, is
Yeah.
exactly what now needs to go into a rules file or into a document for the AI, because
Hmm.
the AI collaborator is always on its first week. It's like it's always the first week for it at work. So uh, yeah, I think that's my sort of take of the unsaid rules that I have right now.
Sure. On governance piece, Sabareesh, and what's the governance failure mode you see most often, where teams think they have guardrails in place, but the guardrails are actually creating a false sense of safety?
Uh, the most common failure mode is mistaking artifact for process.
Hmm.
So so a team writes a guardrail document, checks the boxes, and assumes the guardrails are working. But a document nobody reads is not a guardrail, it's just like decoration. So uh, within our organization, uh, we saw a pattern with a team that used AI to generate design documents.
Hmm.
It was long, well structured, it had all the right sections. It looked like there was a lot of rigorous design thinking that went in. But when you read it carefully, it was full of implementation details that had no business being in like a design doc, and it was missing the thing that makes the design document valuable,
Right.
which is uh, the collision of minds,
Hmm.
uh, the critique, the pushback. Wait, have we thought about this? The comment from another architect in the design doc. That whole process was completely skipped.
Hmm.
The AI generated an artifact. The team the team didn't assume the work was done, but yeah, we assumed the AI had completed its work,
Hmm.
and then the PRs came in from the AI. Each PR over 200 files.
Hmm.
Nobody can meaningfully review 200 files, so there's a lot of hidden decisions, architectural choices that the AI made
Hmm.
that nobody knows why the AI made those decisions. They all got baked into the code base. Uh, no one explicitly approved them, and they're going to surface later when something breaks and nobody can explain why the system was built that way.
Hmm.
It's just going to surface up. So the guardrail that looks like it's there but isn't a document, that looks like it's there but it isn't, is a document that was generated rather than deliberated.
Hmm.
Uh, it, you, I want to share like a very respectful architect in my organization that who I was having a conversation with recently shared a very insightful statement, which is that a design document is a process and it's not an artifact.
Right.
It's a process of multiple engineers sitting together and critiquing each other and trying to come out with what's best. And now you have to do that with AI. So there's a lot of governance involved there that you have to put in place.
Sure. Sure, Sabareesh. We'll move to the architecture, the speed of reasoning and not execution. So you use AI to analyze data flow paths and reason about state boundaries across layers. So can you describe a specific architectural decision at AVEVA or anywhere else where AI helped surface a trade-off the team would have otherwise missed?
Yeah, I'm just finding my notes, sorry.
Sure.
Yeah. So I'll be honest. I think the whole industry is, but we're still in our what we like to call early adoption phase. So we haven't yet reached the stage where AI is catching things in pockets in various teams, but we still haven't identified a pattern where there's something significant that it would have missed. But what's happening right now is what we're doing right now is more foundational than that. And I think it's more interesting. The architectural decision we've made to prepare our code base is to prepare our code bases for AI. So structuring them so that when AI agents are working inside the code, they have the right context to make the good decisions, embedding the markdown files into the repos or descriptions of expected behaviors, guardrails, intent. We're essentially writing documentation right now for non-human collaborators. And that's a very intentional architectural decision we have to make. Most teams are not making it yet. They're adopting AI tooling without actually thinking about how the code base itself needs to change to support it. And we're setting the standards in place now. We're doing that work now so that when AI does start surfacing these trade-offs we have missed, it has the context to do it accurately rather than confidently and wrongly, as it does a lot of the time.
Sure. And you say AI is used to broaden perspective, not to decide, Sabareesh. But in practice, when a team is under deadline pressure, that line can actually blur. So how do you hold that boundary when speed is the loudest voice in the room?
Yes. So I have like two threads of thought here. I'll be honest, the line blurs. The real deadline pressure, it blurs for me as well. The version of this, I believe, when things are calm, is AI can show you more options, but it doesn't get a vote on the decision. The rule sounds clean in a planning meeting. It gets tested every time in a release. It gets tested every time a release is 3 days away, and an engineer says the AI suggested this approach and it looks right, and the pressure to say ship it is real. What I found is that the guardrail can't just live in the principle; it has to live in process. So if I've embedded the architectural intent into a code base, if engineers are already in the habit of explaining their decisions, then under pressure, there's still a structure that asks, did we think about this or did we just accept it? The behavior is already there before the pressure hits. You can't install the habit during a crisis. So, but I don't think I won't pretend like I've solved this. There are moments I've seen and moments I've been in where speed wins, and usually the cost will show up later, sometimes quietly, in a system that you sort of miss the point. The other aspect I will say is considering the whole industry is adopting this, and this is sort of like a simplified version of some talks that I attended at a DX conference. DX is a developer productivity platform, and I attended a conference recently. Is that at this stage of AI adoption that the industry is going through, speed is important, but it's showing up. The cost of that speed is going to show up in various ways. The first thing is the bottleneck is going to move. So if people are producing code much faster, the bottleneck in an organization is going to move to maybe code being reviewed slowly, and so the productivity is going to drop in that part of the software development lifecycle. And then when people address that, maybe by throwing more AI at it, and they'll see the bottleneck moves elsewhere. Maybe product requirements are not coming fast enough.
Yeah.
And so the bottlenecks can move left of the code, right of the code, and there's still a lot of work going on to kind of figure out how to measure the ROI on the speed, right? We're getting a lot of code, but nobody really knows. A lot of organizations are just relying on sort of a North Star that what is the time to ship? How fast are we able to ship something reliable and functional? The challenge is the metrics people are using are things like PR throughput and token cost, and that kind of metrics which don't point accurately at anything valuable, but together they sort of give you a sense of what you're getting as a return of investment for using AI to speed things up.
You touched on Conway's law. Just have one more question around it, and let me know if you've already covered it. So architectures drift when teams reason locally. How are you using AI proactively to make cross-team dependencies visible before they become architectural debt, Sabareesh?
Yeah, I think I sort of answered this across questions, but and I can repeat it sort of. I think the Conway's law is it used to be that your architecture mirrors your communication structure within the organization. And like now you have microservices architectures, so you have like smaller teams working on this thing. And when you had like various different architectures in the past, the way the teams communicate was very different. But now your architecture mirrors your communication structure plus whatever each team's AI filled in when the communication broke down, right? Or even when the communication was up, whatever else the AI is doing. So every engineer with an AI interface is reasoning about the code base from their local context. If that local context doesn't include all of these, like we talked about, these cross-team dependencies and cross-team knowledge that the AI should have, if the AI doesn't know that team A's service talks to team B's in a specific way, it will make locally reasonable decisions that can create global problems. And it'll do it confidently and very quietly. So the proactive answer, I think, is what we're doing at AVEVA is exactly that markdown strategy. So embedding cross-team context, dependency descriptions, behavioral contracts directly into the code base. So when any engineer's AI is working in that code, it's working with a full picture, not just like a local view. It's very early days, but the principle is the AI's context window needs to include the things humans learned the hard way. Otherwise, otherwise the AI is also going to learn it the hard way, and that's going to be at our expense.
Absolutely, Sabareesh. We'll move to the culture before compliance, building teams that question AI, not follow it. You regularly share your AI failures with your team, times when it misled you due to missing context or flawed assumptions. What's one of those moments, and what did it teach the team that a success story couldn't, Sabareesh?
Yeah, I think I sort of shared a little bit of this earlier. The failure I think about, it isn't the most dramatic thing. It's very quiet, and I think that's why it's sort of important. I shared the story of how we did an experimental process to see how an AI can generate a design document. I think it looked complete, and but it had a lot of implementation details where design doc is not intended to have that. And I mentioned about how we talked about a design document supposed to be like the collision of minds and multiple people critically thinking, challenging each other. That friction between people is sort of the point of the whole process. And when AI sort of skips that friction and just goes straight to producing an artifact, you get something that looks sort of like design thinking, but it's really not a design document. So what this has sort of taught the team is AI can generate the appearance of a process very easily, the appearance of collaboration or rigor, but without any substance. And when that happens repeatedly, it's a signal that the agents, the instructions, the guardrails weren't tight enough. The AI filled a vacuum, and it will always fill it if you let it. So every time something like this happens, it's an indicator to just figure out where the guardrails are missing, at least at this stage of where the industry is at.
Sure. I think you might have touched upon it, but I'll still ask you, Sabrish. On your team, engineers are expected to explain why they accepted, modified, or rejected an AI solution. How do you make that a norm without turning it into a checkbox exercise where people explain their reasoning without actually thinking it through? And added to that is another question on, you actually talk about creating space for failure cases and near misses without blame. So in an industry where shipping fast is rewarded, how do you protect that space from being squeezed out by velocity pressure? Anything around these two questions?
Um, yeah, with the checkbox version, with that checkbox question, like, did you review the AI suggestion? Yes, and just go next. Uh, that's compliance, and that's like very uh, robotic compliance, and it means nothing. It tells me nothing. The real version is a conversation in possibly a code review is, hey, walk me through the code that your AI suggested here, and what did you decide to do with it?
Mm.
Uh, that question sort of has quality to it. You can immediately hear whether the engineer has engaged with the output or just shipped it.
Mm.
Over-engineered solutions, ghost functions that don't exist, uh, uh, superfluous try and catch blocks. Uh, these are tells of someone who has read the suggestion and assumed it compiles and builds correctly, so it must be correct. Uh, but then the even more subtle tell is usually like in code review comments themselves. So when an engineer's review is very like shallow,
Mm.
technically it's present, but it's not absorbing what the code actually does. That's like a deeper signal.
Mm.
That's sort of drift. Like, and I don't mean code drift. I mean cognitive drift. Like the engineer is processing,
Mm.
not thinking, because they've sort of gotten so used to working with the AI, and that drift is how you end up with a team that's fast, but it can be very fragile. The norm, I think the norm gets built by modeling it yourself. I try to share my AI failures with my team and things that haven't worked for me. The times it's misled me, the times I accepted something that I shouldn't have, and I'm making it to sort of build that culture to make it safe to say that I'm not sure why the AI suggested this. But sort of psychological safety is what turns that checkbox into culture. And I think
Mm.
having that open conversation, there was a time in the last couple of months, or maybe the last 2 years, where people were judged for using AI, and sort of kind of easing that out also helps. Uh, and I think that sort of will lead that culture will help with this whole problem. Uh, I think there might be more to it, and I'm still learning what else we can add on to this. I think your second question about
It's a
shipping fast getting rewarded, right?
that's
And how do you protect space from being squeezed? Uh, yeah, velocity pressure is real. It does a lot of things. It doesn't give space for people to experiment with the AI and actually figure out where the gaps are. So you're just trying to build like rough systems just to satisfy like the checkbox. If my organization asked me to use AI, so I'm just using it. So that the velocity to deliver is a hard thing. Uh, the honest answer is, I would say the space doesn't get squeezed. The question is whether you've built enough of a foundation that it can survive the squeeze. If I'm not wrong, so and I think that foundation is like what we talked about, like psychological safety. And I think it always starts with the leader's behavior, the leadership's behavior. If I only bring successes to the team, they also only bring successes to me or to leadership, right? Uh, the failures should surface as near misses. Instead, that failures that should surface as near misses instead are going to get buried. They become incidents. So I think that same process, like me sharing my failures, helps the team. Uh, and as the team grows and sort of the deadlines compress, it gets harder. The protective mechanism, I think that might work, and I'm trying to make it work. Is retrospectives should be short and very focused. Should be not like a huge blame storm of who did this, and uh, should be like short. What happened? What did the AI do? What will we add to our guardrails because of it? When it's fast and forward looking, it doesn't feel like you're interrupting the velocity when you sort of make that retrospective decision. And I feel that's how you get faster in the processes in between understanding how to work with this new tool.
Yes, Abhish. So let's move to the last theme on the new engineering manager. curator of context, not coordinator of execution. Uh, Now we're looking at the big picture, what great engineering leadership looks like when AI is permanent infrastructure, Sabareesh. So a couple of questions are, you describe the manager's evolving role as shifting from relay of information to curator of shared understanding. What are the capabilities or what capabilities do engineering managers need to develop right now that most aren't investing in, according to you?
Uh, I mean, I'm not sure if most aren't investing in it, but I think something that I am working on investing more in is uh, this deliberate design of information, of what information AI has access to, in what form and with what constraints, or like sort of that context architecture. Uh, I do think that a lot of teams in uh, who are skeptical of using AI or have attempted to use AI still sort of think of it as a productivity tool for an individual engineer. Uh, and I think that leaders who will lead well 5 years from now are thinking about AI as a part of the team, as a team member that needs to be onboarded with the same care that you give any new engineer. And you got to do it permanently, and you have to do it at scale. That means getting very good with making all the implicit things that you did with humans very explicit for the AI, the unspoken norms, like we talked about, the architectural decisions that everyone sort of knows, the reasons why we're building things the way we do. All of that needs to live somewhere that the AI can go and read it and understand it. And I think that manager's job is sort of going to be a little bit of figuring out how to curate that context of culture and where you put it so that the AI can read it. Uh, Not to write all of it, but to know what's missing and ensure, like, identify what's missing. Like, what are things that my engineers sort of can feel out and figure out from each other, but uh, the AI cannot, and it gets missed. So, and ensure that it gets captured so that doesn't cost us. And I think the second capability is, I'll call it AI skepticism as a leadership practice. It's not distrust. I think it's like skepticism, the ability to look at AI generated output and ask, like, what's missing here? Like, what assumptions did it bake in that we didn't make? Uh, and I think we're all still like amazed at what AI can do. We're very impressed by the output of AI, and I think it's important to keep that skepticism alive, just like curiosity and skepticism that you should always have as an engineer. Uh, and I guess the ones who lead well are the people who are hardest to impress. I could say that.
I think you built production mobile apps solo using AI as co-creator, Sabrish. How has that personal experience of shipping end-to-end with AI changed the way you set expectations for your team on what's achievable?
Um, yeah. So the first thing is I'm always experimenting. Like, I'm the 1% early adopter. When something comes out, I'll go try it and see what it's capable of, what breaks, what it can't do. So when building this event management app that we did for a nonprofit, we used React Native. It had a Supabase backend. We shipped to two stores, the Google Play Store and the Apple App Store. It's been used at 3 conferences now. It changed something fundamental in how I think of what's achievable with a small team. Uh, so we were multiple developers. We all were using different AI tools. I think Cursor, Claude, Copilot, and we almost had like zero friction between platforms, which surprised me. And the reason wasn't because we standardized the tool or anything. It was we standardized sort of discipline and the culture of how we interact with these tools. Uh, and we standardized the rules and the size of tasks. On the rules, like I think I mentioned it earlier on how we talked about how data migration should never be deleted and always rollback ready. Uh, Made sure that everyone's AI followed that rule. On tasks, we kept the tasks very tiny and focused. Changed the label on the UI for this one. For this one part of the UI was one prompt, and then improving the spacing was the next. We were not giving the AI any room to make assumptions. Uh, and I'll say this because the reason we did it this way was this was also when the models were pre-December 2025, when there was a lot of hallucination, they were not really, that jump to being able to code really well did not happen yet. And I think the hardest part of all of that was our debugging, uh, because these models had a real ceiling at the time. But once they improved, that ceiling got lifted. The shipping speed on features was like anything. I was really impressed. Solo or in small teams. Uh, I think I wouldn't say something has changed in my teams yet, but I am observing the change, where people are now producing obviously more code, and their approach to working is more agent orchestration versus and system design versus like, let me write the code and doing the data structures or the nitty gritty part of it. They're designing the data structures, but not the nitty gritty part of it. And I guess the question I now ask because of this has gone into this, like, I'll repeat this again, like, do we have enough context and discipline in how we are using, as a manager, how we're using the people and the AI we have? There are different problems or different solutions. Like I know that I have a person on my team who's really good at pipelines and can set up the CI and the CD part of of the process of our software development really well. I know someone who's really good at C++ and the Linux side of things. So there's like distributed context amongst people. So now you're also adding AI in the mix that may or may not might have like technical expertise, but might miss some of the context of what these people know ingrained in the organizational know-how.
Yeah.
And I think that's what is sort of changing now for me.
Absolutely, Sabareesh. So last one, now if you had to identify one thing that separates engineering teams that will thrive with AI over the next 5 years from those that will struggle, what is it, and why it is so hard to develop, Sabareesh?
I would say it's not the tooling, it's not even the talent, it's the team's relationship with uncertainty, because that's sort of where we are at. Specifically, the comfort of sitting with a question long enough to actually think about it before you hand it to an AI. And the teams that will struggle, I think, have sort of already outsourced the discomfort of not knowing. They reach for the AI the moment a problem feels hard. And the AI gives them something that looks like an answer, sounds like an answer, it compiles like an answer, and builds like an answer. And the muscle that should have been exercised, oh, I don't know yet, let me think, muscle that starts to get weaker every time you sort of do this. And I'll sort of go back to that quote that Demis Hassad said, which, if you use AI in a lazy way, it'll make you worse at critical thinking. And I think that's so true. Like the teams that will thrive are the ones where they're not a warning. That's not a warning they're hearing for the first time. It's like a principle they've already built into how they work. And why it's so hard to develop, I think, is because the short-term feedback loop rewards the wrong behavior. Because you're doing something and the AI gives you something so quickly, and that sort of feedback loop that you're getting, it's like the wrong behavior. The shipping fast feels so good. It's like instant gratification. So the AI generated the design doc. It skipped the real conversation. It looks complete. Oh, I got a PR with 200 files. Oh my God, I did so much work. The cost is invisible until it's not. Until something breaks in the system, nobody fully understands that system, and the team realizes that they have the velocity, but they've sort of lost comprehension. So I think in closing, like the teams that thrive will be the ones who recognize this trade-off very early, and early enough to do something about it.
Absolutely. Absolutely, Sabareesh. I mean, thanks so much for taking time. Typically the entire questionnaire was actually designed to draw out the hard won specific and sometimes counterintuitive insights of yours that actually come from deep practitioner experience of yours. Sabri. So, I mean, the aim of the entire podcast was to serve three audiences simultaneously. The engineering managers looking for a practical leadership model for AI adoption, senior leaders navigating the balance between AI leverage and engineering rigor, and the organization leaders trying to understand why culture and not tooling is a real bottleneck in AI transformation, as you very nicely summarized. So we looked at five themes, right from segregation to integration, and you took us through the evolution of AI in engineering. We looked at guardrails without bureaucracy and governance that engineers actually follow. We moved to architecture, the speed of reasoning and not execution, and also culture before compliance. Finally, I think we looked at the new engineering manager, the curator of context and not coordinator of execution. Uh, Thanks a lot for your insights as such, and very very interesting insights according to your experience, Sabrish. Anything else you actually want to share to these three audiences who will be very much looking forward to this podcast?
Uh, I would say with AI coming into the picture, there's a lot of fear in the market and the industry. Uh, I would say it's best to embrace things as they come, see what works, and kind of uh, embed yourself into the process and evolve. Uh, and it's sort of I think there's a Carnegie Mellon Microsoft research sort of quote that I've read. I'll try to paraphrase it, but the key irony of automation is that by mechanizing routine tasks and leaving the exception handling to the human user, you deprive the user of the routine opportunities to practice their judgment and strengthen, the cognitive musculature, and you leave them feeling weak and unprepared for when the exceptions do arise. And that's sort of like exactly what AI is happening with AI now. That you have to understand it really well enough so that you're well prepared for when the exception arrives, and you have to figure out how to deal with it and not be left behind.
And one last question, I've been, closely involved with IT, work with Wells Fargo, the last stint of mine. How was it earlier before AI took over? How was it actually, how did work look like before AI, and how is it now? How is it now? You actually explained throughout this podcast, but how was it earlier? Because the critical thinking part of it, the ability to analyze is something which was a given then. And now I think that lines are blurring because AI is actually taken over. What's your perspective? And that's the last question that I have, Sabrish.
Uh, yeah, I think that there's this. We should be very cognizant of the over reliance on AI. Particularly when developers are blindly adopting suggestions or eroding that'll erode your critical thinking. And I think at the core of it, we're all still engineers. We're responsible for building systems that uh, affect the real world and people using them. We at AVEVA are building industrial software that produces vaccines, or that affects power and natural gas systems in the world. So in our little bubble of using AI and building these systems, we have to be very cognizant of what we're doing so that these systems don't break. We always were, and we always have to be. So these guardrails now become so much more important because you have this undeterministic player in the loop now that needs to uh, follow. And then there's also the sort of educational side of it, like the there's stories of like the 14-year-old hacker kid who joins Facebook uh, when that was a very cool thing to have. Now literally anybody can write code and anybody can stand up anything. So, and developers, there's studies of like lower number of computer science graduate students and undergrads being admitted into college because that's a field that they feel is not going to exist because the robots are going to do everything. Uh, but the ones who do also pick this up are losing out on like or missing out on all the foundational learning. Where situations where like only the senior engineers on a team understand like the architecture and design and decisions, but the junior engineers are like, oh yeah, you guys already have embedded everything in the code base with all of this context, and I'm just going to use the AI to do your task. I mean, the role of a software developer is evolving. It's going into this agent orchestrator and system designer, and that is sort of becoming the role. But I still think that all of the foundational knowledge of data structures, understanding performance, and all of that uh, is still very critical to an engineer. Yeah, I think just the more confidence that someone has, it's very counterintuitive, but the more confidence that someone has with generative AI and using them, the less likely they're going to use their own critical thinking to engage with the work. They're just going to blindly sort of go into it. Uh, yeah, I think I just want to say we just have to be cognizant of that. And I think we were, we were always cognizant of that, and we were forced to be cognizant of that earlier. Now there's like a lot of comfort for us to rely on, like how I think the whole idea of going to a library, reading a book, and figuring out what the solution is changed once Google came out, and it became everyone's like, yeah, well, I'll just Google it and I'll find the information. Oh, the moment someone struggled, I think Stack Overflow did that for a time. Right? When someone struggled with something, like, oh, I'm just going to find the solution, Stack Overflow. I'll just post my answer there. Someone will tell me how to do it. And that's now shifted to AI, which introduces it's much faster and introduces a whole bunch of things, and there's like no bounds to what it can say or tell you.
Absolutely, Sabareesh. I mean, thanks so much for your time today and answering our questions. And I'll pull you in for another episode with another topic. I think that's all we have for today. And thank you so much again for your time, Sabareesh.
Of course, no problem. No problem at all.
Thank you.